Okay, welcome back. So today we're going to be looking at question 1B from the Oxford MAT exam. This is the 2018 paper. And the question is this. So we're given this fairly nasty differential equation. So it involves y dy dx and the second derivative of y. And we're given this function, so y equals e to the kx. And the question is, for what values of k does this equation hold? And in particular, how many values of k is this equation true? So it's actually, although it looks quite scary, it's actually quite straightforward. All we need is to calculate dy dx and d squared y over dx squared. And then we can just sub it in. So this is fairly straightforward. We can do this. So if we have y dy dx, first derivative, remember k is a constant, so we just bring the constant to the front. We have k times y. So the derivative of the exponential is just itself. So this is the first derivative of y. And we're also going to need the second derivative. So we go ahead and just do that. And we obtain that by differentiating this expression. So remember, k is a constant. So we can just bring down another factor of k. So it's going to be k times e to the kx. So simplifying, that's just k squared times e to the kx. That should be fairly straightforward. So now we have these values, we can just input them into this equation and then do some rearranging. Okay, so subbing in, we have k squared e to the kx. We have plus k e to the kx. We also have times dy dx, so we have another k e to the kx. Minus y, which we know is e to the kx. Make it run out of space. And then we also have the right hand side, which is just y, so e to the kx times k times e to the kx. Okay, so now we just need to simplify. So we can collect some terms. So on the left hand side, everything has a factor of e to the kx. So we can bring out this term here, and we can bring it out of this bracket here. So we're going to get two lots of e to the kx. So we're going to have e to the kx squared, which we can simplify. We'll do that in a second. And what we're left over with, we've got a k squared. We have a k as well. That's the first bracket. Second bracket, we are left with, if we've taken this factor out as well, this is what's come out the front, we are left with k minus 1. And on the right hand side, we have two lots of e to the kx, so again, e to the kx squared, e to the kx squared, and we also have the k in here. So now we have e to the kx squared on both sides. We can put everything on one side and simplify. And just remember, when we've got an exponential, when we're squaring an exponential, we can just, it's the same as just multiplying. So we can actually bring the 2 in the front here. So we have e to the 2kx. This is just the laws of indices. And if we rearrange and bring everything onto one side, we're going to have, okay, so bring out the k here. I have k times k plus 1. So I've just brought out a factor of k from this bracket. And we still have this bracket. We can't do anything here yet. K minus 1. And as I was saying, we're bringing everything onto one side, so we're just going to subtract a factor of k. And if we were to expand this out, this would just correspond to this term. So now this equals 0. So now we have a polynomial, and we have this weird looking thing which we want to get rid of. So we can't really do much for this. But what we do know, this, if we just do a quick sketch, remember what the exponential function looks like. It's kind of, it grows very rapidly like this. But the key insight is that this function never equals 0. For no values of x or k, is this function ever going to equal 0. So no matter what values of k or x we put in here, this left-hand side is never going to be equal to 0 just from this term. So we can just divide through by it. We can get rid of it. So just forget about it. And then we're left with a nice, this is a cubic. So we can do a bit of simplification. And this is nice because we can factorize it. Normally you wouldn't be able to solve a cubic, but because there's a factor of k in both of these, we can just factorize that out. And we're going to be left with k times a quadratic. So k plus 1 times k minus 1. This will come out as k squared plus k minus k minus 1. So these cancel, obviously. And remember, we factored out a factor of k, so we're going to get to minus 1 again. this equals 0. So let's just do a little bit more of simplification. K times k squared minus 2. I'll just move over here in case we're running out of space. So this is a difference of two squares. We can factorize this again, and we're going to see we're going to have a cubic in factored form. So we're going to have k minus the square root of 2 times k plus the square root of 2. And this equals 0. So this, if we were to expand these two brackets out, we just get k squared minus 2. So now we know what the solutions are, right? We just take each bracket, set it equal to 0. Solutions are k equals to 0, k equals plus the square root of 2, and k equals minus the square root of 2. So these are the three solutions. So we've just worked through the question, and these are the values. If you remember the question, these are the values such that this equation holds, and that's the question. So to answer the final question, we would just say there's three solutions. So that's the answer.